Sorry it took me so long to get this video out to you guys. So there's a question about number 14 and number 17 from the worksheet. I also wanted to take a moment and just talk about limits as x approaches infinity in general. So do you see, so first we'll do a little example. So when you have a limit as x is approaching infinity, do you see how if I plugged in larger and larger numbers into the numerator, it would like grow without bounds and approach infinity? And then the same thing with the denominator. This would also approach infinity. So this is another indeterminate form. Just like 0 over 0, infinity over infinity is an indeterminate form. And you're allowed to use L'Hopital's rule to evaluate this limit also. So we're going to rewrite this limit as x approaches infinity, and we're going to take the derivative of the top and the derivative of the bottom. So do you see how now the top, approaches 0 or 2, but the bottom approaches infinity, and 2 divided by infinity, well, that'll go to 0. Because it's kind of like there's 2 cookies and infinitely many people, you don't get any cookies. So that's one way to do it. The other way to do it is just to kind of like think about it. Like kind of think about like who wins, the numerator or the denominator. We did these kinds of limits before. So do you see how here the numerator is not growing as quickly as the denominator? So because the bottom wins, the limit is 0. All right, so now let's look at number 14. So number 14 had a couple natural logs, which, makes things confusing in general. So I think the easiest way to do this one is to use the properties of logs where you can bring this exponent to the front. So before you take the derivative, both the numerator and the denominator approach infinity. So we can like apply L'Hopital's rule. So before we take the derivative though, let's just rewrite this to be like 2 times the ln of x over 3 times the ln of x plus 4. So now when we take the derivative of this, we would get 2 times 1 over x over 3 times 1 over x plus 4. And let's just simplify this. So this is really 2 over x, and this is really 3 over x plus 4. And then if you're dividing them, can't you like flip and multiply? And then now you can kind of see that like the bottom and the top will tie here. So you're going to take the ratio of the coefficients, and it's 2/3. If you have trouble seeing that, you can always just take the derivative of the top, take the derivative of the bottom. So the derivative of the top will be 2. The derivative of the bottom will be 3. So your answer is 2/3. So now number 17 was just a tricky one. So if you plug 0 in, you get the square root of 1 minus 0 all over 0. So the top goes to 0 and the bottom goes to 0. So let's apply L'Hopital's rule and take the, that's just a limit as x approaches 0. The derivative of the top would be 1/2 1 plus x to the negative 1/2. The minus 1 would go away, and then the derivative of x over 2, isn't that really just like 1/2 x? So the derivative of that is just 1/2. And then all over 2x. So if you go to plug 0 in again, you still get 0 over 0. So we have to do it again. So now, bring this negative 1/2 down, will be negative 1/4 times 1 plus x to the negative 3/2, and then the minus 1/2 will go away, all over 2. Now we're going to plug 0 in again. So 1 plus 0 is 1 to the negative 3/2 power, that'll still be 1. So this ends up being just negative 1/4 over 2, which is negative 1/8.